Hey, what's up guys? Welcome back to the channel. Today on the channel, I'm going to show you how to build this portable power station, so stay tuned. Alright guys, so before we get started, I just want to drop a quick disclaimer. Everything we're about to do here, if you're a purist, turn away from the video because we're not about to do everything 100% by the book. We're going to take a lot of safety precautions and build things in a more correct type of manner, but it's not going to be 100% code or by the book. So there's your fair warning. So turn away now. Remember, I'm not telling you to build this. I'm just telling you how I built it. If you hurt, injure yourself, burn something down, shock yourself, whatever, it's not my fault. I'm telling you, don't do it. This is just telling you how I built it, just in case somebody wants to take an idea and make it better. Anyways, everything you need right here, everything you need to build this is on this table. This is a rigid small toolbox. You can pick these up at Home Depot. I think they're like roughly like 15 or 20 bucks or something like that. This is the one I had. I used it a while, but I don't use this one anymore, at least not in the truck, primarily because it doesn't fit. So I retired it to carry this power station around. So once you get rid of this, it's not all that much. This is going to be a pretty simple build. On a level of difficulty, I would probably put this somewhere between a low and a medium, more towards medium if you've never built something like this before. If you've done a lot of electronics and building stuff, this is probably going to be pretty simple for you. And let's talk about this inverter. So this is the inverter that I picked up. I think I picked this one up by Amazon or something like that. It had pretty decent ratings. I used 2,000 watt inverter. I think it surges somewhere around 3,000 watts. I don't really need 2,000 watts, but this is one of the lower ones that I could pick up. And went with the 36 volt one. You could go with a 12 or a 24 or 36 or any of these. If I were you, I would go with 36 because most of the batteries that we're going to be using are 18 volts. So if you put two of them in series, you can get 36 volts. If you remember anything from the first video, the higher voltage you go, the less amps you need to carry to pull the same amount of power, generally, okay? So this is the inverter that I got. When I bought this inverter, it came with two of these wires. We're gonna use these wires. If you buy an inverter and you don't get it, don't worry, you can just use some extra Romex or whatnot laying around. Romex is the brand. Let's just call it solid core wire, okay? So this is the inverter. We'll put that aside. Let's talk about some of the other stuff here. You also need You're also going to need two of these 3D printed battery block holders for whatever battery system or platform that you're using. These right here that I'm holding in my hand are the Bosch ones. I use these in a separate project somewhere else, so I had two extra ones here. But you could technically print these out if you have a 3D printer, and I did that a couple of times, but it just took forever, so I just spent, I think it was like 15 or bucks or whatever per piece, and just pick them up. And I picked these up off of eBay, and they seem to be the best place to get them right now. I'll throw a link in the description to where I picked them up. But the one that I got here is pretty good, primarily because the print quality is pretty good, has the mounting holes, has the battery clip, and it comes with 12 gauge Southwire cable. This comes with the crimps already installed, the spade connectors. You need to get at least two of them for whatever battery platform that you're using, okay? I would definitely recommend 4, but you need minimum of at least 2. So if I were you, get the 4. That way you can use 4 batteries and need to carry a lot less amps from the batteries, okay? You also need whatever tools for the distribution blocks that you're going to get, but these are pretty much just straight up hex wrenches, the Husky kind. Don't worry, nobody's sponsoring this video. This is just the one that I have in the garage, so we're going to be using that. You also need some pretty good or decent quality diagonal wire cutters. You also need some wire strippers. I used to strip wires old school way, just take it like this and split it, but time's sake or whatnot, I know a lot of people use these. This is the Irwin one. Like I said, no one's sponsoring this video or anything. I used to use the Klein ones, but they kind of wore out. I don't know why, but they seem to wear out a little bit faster than they used to in the older days. But anyways, get yourself a good set of wire strippers. Then let's talk about this. This is pretty much a circuit breaker. And why are circuit breakers important? Because we want to be as safe as possible, right? But this one right here is rated at 60 amps. Okay, so like I said, remember, we're erring a little bit on the safer side on the fuses side, because you want to protect the inverter as much as possible. Okay, because fuses are easy to replace, but the inverter is actually probably the most expensive item in this whole build. So you want to protect that one as much as possible. I don't ever plan drawing anywhere near 2,000 watts from this system or whatever, but you could go a little bit higher if you wanted to, but I would recommend erring on the safer side to protect your investment or your electronics. This one's pretty simple because this one's resettable. You connect it here, you engage it. If it passes the threshold, it'll trip, and you can always reset it. You need a distribution block. This is a distribution block. These things are mainly used in car audio, but we're going to use these here because these are pretty good quality, and I have a lot of experience installing car audio systems. So this is what we're going to use. I picked this up off Amazon. 4 on one side, 1 on another. This is a distribution block. You also need this. This is another distribution block. Can't remember what the brand is. This is DS18, but the good thing about this one is this is a 4 on one and 1 on the other. Technically it's a 3 because there's 2 on each side, but we're not going to use them. So you really need like a 1 and 4 system. The reason I went with this one is because this one has a fuse for each strand or each leg, depending on which industry you're talking about, but fuse for each strand. These fuses here are what they call mini ANL fuses, okay? And this one right here doesn't have a fuse because we're going to be grounding the negatives on this side, and we're going to be using the positives on this side. So you want to protect each leg of the circuit on this one. So this one, the one that I got, came with, I think it was 60 amp fuses, which is kind of why I also have this, which are 40 amp fuses. These are a little bit lower fuses. Like I said, error safer on the fuse side so that you can rather trip the fuse than break anything else. I would realistically, if you're building, I would tell you to mainly go with maybe a 20 amp or a 30 amp. I'm going with 40 amp because I kind of understand how the system works and how we built the system, and I'll probably take a little bit more risk than some of you guys, but 40 amps, I'm going to switch these out to 40 amp fuses, okay? So pick yourself up some good 20 or 30 amp fuses. You'll be good to go. All this stuff will be in the description below, and you can pick these up off Amazon. Almost everything here came off Amazon. Don't worry, nobody's sponsoring this video. These are what they call diodes. And if you don't remember, diodes let current or power pretty much flow in one direction. Okay, somebody commented these diodes are pretty much overkill, and yes they are. Why did we go with this? Primarily because the other diodes I used to use, the ones that look like resistors, they actually burnt out fairly quite often. I think it was reaching a little bit higher towards the rated specs, but these will work pretty good, and you'll see why I really like these versus the other ones in a little bit, because when we build this, you need at least 1 diode for each set of batteries that you're going to use. Meaning, if you have 2 batteries, you need 1 diode. If you have 4 batteries, you need 2 diodes. Okay, like I said, build with at least 4. That way you can draw a little bit less amps from each battery and be a little bit more safe, or whatnot. Anyways, that's all the stuff you need for this. Oh, there was some 3M mounting permanent double stick tape. You can use Velcro, whatever if you wanted, but the 3M tape that I use actually is really strong, the Extreme Permanent Mounting Tape, and that's pretty much what's holding all of this on here. I mean, look, there's pretty much about 1 inch on here, and I could not get this off even if you tried. If you really tried, you could, but so I took a lot of effort to get one of those off, but I just want you to see how strong it is. It's going to pick it up straight like this. This is not going anywhere anytime soon. So I love that 3M tape, and without further ado, let's get to building it. All right, guys, as we're building it, let's go over pretty much a quick schematic of how this is pretty much going to work, okay? You're going to have a positive and negative lead coming out of each one of these. And I would also 100% double check that the positive one is the red wire and the black one is the black wire, okay? I mean, nothing bad about the people that are selling these things, but you never know, it could be wrong. So take the battery, check on the battery which one's positive, which one's negative, and make sure it lines up and the red is positive. Okay, it's telling you, it's always good to double check that. So pretty much in order to get 36 volts, you need to take at least one of the positives and feed it into the negative of the next battery mount. Okay, so technically speaking, these two leads right here, how do you make this more clear? These two leads coming out, one negative from one and positive, are going to be combined. Okay, you can just take a wire nut and combine these if you want. I actually did a little bit of a hack where you can pull these out and feed it through here, and then just crimp another spade connector on there. I'll show you how that I did that real quick. So like for instance right here, there's two of these, right? I mean, I took a permanent marker and just marked plus minus to make sure that I can never really get confused on which one's plus and which one's minus. So positive here, negative here. Okay, so take the positive of this one and feed it in to the negative of this one, and then put the spade connector there. Okay, same deal with this one. Positive of this one and feed the negative of this one. Yes, somebody's probably gonna say, oh, you should put a fuse right there, but hey, we're not living in the perfect world. All right, you can put a fuse there if you want, but two of those. Okay, so what's pretty much gonna happen is you're gonna have two of these. It's gonna be connected like so. Your power is going to come from here, and it's going to feed into a diode. Okay, I'm not connecting it right now, but it's going to feed into a diode like this, and then the diode is going to connect to one of the legs on the distribution block, and all this will be in a wiring schematic that's linked in the diagram below. So if you want to use that, I'll just throw it up here, and you can just pause it and look at the wiring diagram. Okay. All right, guys, so let's get to building this. Okay, like I said, one of the first things that we're gonna do is we're going to swap out the fuses. Since 60 amps I think is a little bit high, we're gonna be using 40 amps, okay? And yes, those PRs are gonna say, hey, you're using 12 gauge wire, you probably really shouldn't exceed 20 amps or something like that, but hey, like I said, we're not living in a perfect world. A lot of these wire runs are really short, and I'm not building this for max case use. Like I said, make sure you know what you're going to be using it for when you build this thing. All right, but pretty much take the fuses out and replace them with lower gauge fuses. I'm going to replace with 40 amp fuses here, primarily because I understand the risks and I'm willing to take some of those risks in some situations, but mainly because I don't really ever expect to be using 2,000 watts out of this inverter. Like I said, a lot of times these are just used for CPAPs or LED TVs on tailgating or something like that, and those things are not going to draw anywhere near 2,000 watts. 2,000 watts, I mean, even a microwave are about 1,000 watts, okay? So 2,000 watts is a lot. So I don't plan to do that. So anyways, pretty much take all your 40 amp fuses, put them in here. In this project, we're only really going to be using 2 of these legs, but it's good to have 4 of these, primarily because if you're out using it and you blow it, you always have a backup. I'd rather be a little bit more safe and blow the fuses rather than blow the inverter. Actually, technically, this inverter has fuses in it, so you should be a little bit safe, but safety reasons, going with lower fuses. Like I said, these are mini ANL fuses. Okay, they make ANL fuses, but they're a little bit bigger. For the sake of this project, we're going to be doing that. All right, guys, so before we get too deep into it, let's talk a little bit about the layout here. This is just the layout that I went with on this inverter. You can figure out whichever layout you want. If I could do this over again, I would move these more over to the edges. That way to free up more space here because it gets pretty cramped. Like I said, the 3M tape I use is it's permanent mounting tape, so it's really hard to get off. I mean, this stuff is not going anywhere without a good amount of effort put into it. But, like I said, look how strong this stuff is. you could probably hang this off of this thing and it will be good for months, if not forever. So I would move most of this off to the edges, move this one more off to this edge, move so that we could free up more space because it gets very cramped here. But make sure that you leave enough space such that if you use the bigger, fatter battery packs that you have space. For instance, I think this is the Milwaukee one. Let's check. Yes, the Milwaukee one, and this is a 12-volt battery. All right, and if you put it here, it comes a little bit here. Yes, you could have put another one here or made them closer. I made that mistake, so if you're gonna do that, don't make the same mistake. So here, the positive lead, or the positive terminal is here, negative terminal is here. But remember, when you flip it like this and put it in, positive comes out there, all right? So Milwaukee battery goes like this. So when you do that, remember 36 volts, 18 volt batteries, you need to put them in series. What does that mean? You take the positive of one, you feed it into negative of the other, and then whichever positive one comes out, this is going to be the positive lead for your battery pack, meaning this pack, these two batteries, okay? So this is pretty much going to feed in, or you're gonna connect a diode to here, and I'm gonna wire it, pull this off, put it like this, turn around here, twist it, maybe solder it. And then this is going to feed into the distribution block like so. I'm going to throw up a wiring diagram on the screen. You can feel free to pause it, screenshot it, whatever. This is just my wiring diagram. You could do it whichever way you want. All the positive leads are pretty much going to go to diodes like this, each one in its own leg. So if you make one with 4, 5, 6 sets or whatnot, you're going to need as many of those diodes. But each one will go like this, feed into a leg. And then from this combined block of all of them, you will feed in to the circuit breaker. Okay, this circuit breaker is going to protect pretty much the whole, all the power going to it. You really technically don't need this because you had the fuses, but I might put this here. And then from this positive, you're going to feed to the positive lead of the inverter. Okay, so it's kind of almost though protected in a way, but it's close enough. All right, so that's pretty much how this is going to work. All right, guys, so for me, I didn't really mention this in the video, but I would pretty much walk into Home Depot and get something like this. If you have a rubber isolation pad or something, you could use that too. Actually, that's definitely the better one to use. Technically, you don't really need to use this in this case, primarily because this is covered with a bunch of plastic and you're going to be pretty safe here. But one of the things I worry about is these screws getting loose, eventually falling down and then energizing the screw in that. You could technically take some, what do you call it, a hot glue and stuff it in there and it'll be pretty safe. But this is pretty much a life-proof plank. I just picked up at Home Depot. Not particularly for this project, but a flooring project that we were working on. And I was just looking around what we had, and this seems to be almost perfect for this. So this is just an extra layer of protection between this and the inverter, all right? All right, so make sure you get a good solid in there. And this one, I think technically you should be using, I think it was like a yellow one or whatnot for this gauge, but the better it fits in there, the better the crimp is gonna be. So I like using this one, especially because the slot here is better fitted for this, this diode here, okay? So make sure you get a good clean, what do you call it? Strip. Take the crimper, put it in there. This one's blue, so I use the blue one right here. You don't technically need to crimp this. Like I said, you could solder it or wire it up a different way if you want, but I'm going with crimper primarily because it's the easiest way, and sometimes taking the easiest way is for the most time benefit. Gonna do that. I like to do a little bit something weird and take a little bit more on the red one to make sure you get the tightest crimp possible. Some people are gonna say, hey, don't do that, but hey, I'm going with it, okay? Then you can feed this diode into here, like so. Look at that. Look at that fit. That's a good fit. For me, I like to take it take some linesman pliers and just give the part right here a good press there, because you get a good, see, that's a good fit. Okay. I'm not going to wire this up perfectly, but hey, you'll get the idea. So I put this here. Let's take this. I'm going to put this here. All right, guys, so the basic setup is there. We've got two sets of batteries, meaning two sets of 36-volt batteries, meaning 18, 18, 18, 18 series feeding into this distribution block, or in our case, a combiner block. Same purpose, it's just going a different direction. And we're feeding into this circuit breaker, and then it's feeding into here, okay? So remember, you should always test as you go. Don't get all the way to the end and think, oh, it doesn't really work. But so we're going to test as you go here, okay? So, and a quick important note. When you're using the batteries in here, yes, you could use pretty much almost any battery, but I would make sure that your batteries have relatively at least close to the same voltages as possible, or at least charges, the easy way to put it. If you don't have a multimeter and test each one, or if you're in a quick run, just make sure that the battery gauges are relatively near the same, if not the same. See, these two are fully charged. 12 volt, 9 my other 12 volt wasn't charged. These are two DeWalt FlexVolt batteries, 3 bars, 3 bars. Like this set is close to the battery set here too, but for the sake of, that's just advice, but for the sake of this, we're just gonna go ahead and give it a quick test. So before we turn everything on, remember the circuit's broken right now. So before we turn it on, I'm going to, let's plug these batteries in here. It's a DeWalt setup. Plug these DeWalt batteries in there. All right. So let's test this DC voltage. Hope you can see that. So DC voltage, positive. Let's test this positive lead here. Test this negative lead here. All right, we're getting 40 volts. Remember, these are 40 volts. Each battery is 20 volts with no load. That's why they market it at 20 volt max. Under load, they're about 18 volts nominal. So that means it's good. All right. So I would make sure your breaker is off. I'm also going to show you that this is a non-contact voltage sensor, but this is pretty much a multimeter. This one's actually very interesting because this one can do a clamp amperage of DC and AC. Most of the ones right now, most of the ones you'll see will only do AC, but this one will also do DC. And this one was fairly inexpensive, and it's very good for what it is, or how much you paid for at least. So I'll leave a link to the description for this. So let's turn this on. Look at that. As you can see here, right now we're reading 39.8 volts. Let me make sure you can see that. 39.8 volts, okay? Bring you guys down. 39.8 volts. You guys can see that, all right? Bring this back around here. Right now there should be really nothing going to it, but the way you use this, we're gonna go to, I don't know, let's just say 20 amps right now. Go to DC, zero it out, put it on the positive lead here. It's kind of upside down for you guys, so you can't really see it all that well, but at rest, it's just using 0.5 amps, okay? Maybe I could put it here, maybe better. Not sure, it's upside down, but hey, if you guys wanna see it, 0.5 amps, okay? So let's give it a good test. Let's turn it off first. If I were you, I will turn it off first before adding batteries. Technically, you could hot swap the batteries, but it's always good practice to turn it off. Do it while it's off if you can. If you're in a situation where you can't, which most people are not going to be in, then don't. I actually have on the bottom side here, you see a grounding wire coming out here. If you can see that, let me see. Grounding wire coming out here, so I could take a, what do you call it? Like an extension cord and ground it when I go somewhere and the ground is near, but not 100% necessary, but I will definitely do it for safety if possible, okay? So, 2 fully charged packs. Actually, let's talk about this. All right, guys, so let's talk about this real quick. This is what we're going to do a quick load test. This is a Meili or Miele, depending on where you're from, Miele Compact C1 pure suction line. And the reason I picked using this vacuum is because you can do variable speed, or at least power. So it looks like, according to this, it'll draw about 9.5 amps. So 9.5 amps times 110, do the math. That's how much wattage that it's going to draw. Let's see how this goes, okay? Just if it's easy, just do 10 times 110, just add another 0. That's almost 1100 watts or so. But like I said, let's see how this goes. Let's take this out, plug it in here. Let me turn this around for you guys. We'll take this out and plug it in here, and I will connect this to here. It's turned on. .40 volts on the battery side, putting out about 122 volts AC here. Right now it's drawing 0.58 amps, pretty much doing nothing. So let's see how this goes, all right? Right now it's on the minimum, the lowest setting right here. And everyone knows running a vacuum is pretty difficult. All right, we got 5.9 amps. And walk around the other side. 5.9 amps. So turn this way so you guys can see it. We'll turn it up to the next setting. Remember, this is on the DC side, not on the AC side. We're drawing 9 amps. This is pretty much level 3 out of 6. 13 amps. Remember, 13 amps from the combined battery set. So relatively, you can do a rough estimate saying roughly 7 amps here and 7 amps from here. Oh, overloaded. That's just on this because I had it on the 20 amp setting. So let's take this off. Let's move this to the 100 amp setting. Switch it to DC. Zero it out. We're drawing 21 amps, 22 amps from this battery set. Okay, so that means each battery set is pulling, or you're pulling roughly about 10 amps from each battery set. Let's see what happens if we go here. I'm not sure what's going to happen. 26 amps. That's pretty good. 25 amps. Maximum setting on the Miele Compact C1. Here we go. Maximum setting for this vacuum, you're going to be pulling about 31 amps from the DC batteries. Relative math, rounded to 32. That's roughly around 16 amps per battery set. Okay, that means these two batteries, you're pulling 16 amps from them. Remember, in series. So, as you can see, works pretty well. There's no real shenanigans going on here. See, there's a glare here. This is an extreme test. I would not do this. All right, guys, so that was a pretty extreme test. I mean, I wouldn't expect to run vacuums. You technically shouldn't run vacuums, something like this. I just did it to show you that what it could do. I think it was pulling 32 amps from the DC side. So that's quite a bit. So if you're gonna do anything more than this, I would definitely go with more battery packs. Like I said, you can create pigtails and connect them all in. I didn't show that in this video because that's really more of an extra feature that I just kind of built into it, but that's good. So like I said, extreme test. I do not recommend you do this, so don't do it. But if you're just pulling like a 55-inch TV, LED TV or something like that, it's gonna be maybe 100, 200, 300 watts max, and that's fine. So see, works. I just wanted to show you that it works. That's pretty much how you built it together. Now you just need to take glue or whatever fastening material you want to use, Velcro, double stick tape, and mount everything permanently. That's all that's really left to it. Like I said, all description, links for everything will be down in the video links below. You can click on it. This has actually been really nice. Talked about this already. I would get one of these if you're doing anything electrical and you don't already have like a Fluke or something better. So that's good. One more quick note here is after you remove the battery packs, the inverter will still be energized, meaning the capacitors, inductors, and stuff will still have energy in it. So make sure you're extra careful and do not short anything out. Okay, so easiest way to do that, besides take them out, take all the batteries out, and just let it dissipate over time, which you need to do anyways. You remove all the batteries. Wow, that's on there really not tight. Remove all the batteries. I'll take this out. There it goes. Just let it beep out, and it'll dissipate most of the batteries or the power left in the inverter. And then I'll just leave it on, just let it dissipate for a while, and it'll go away. But if you're using this mainly for CPAP reasons, like emergency power, don't use it every day. Unless you're in a dire situation, you need to. But those things do not draw that many amps, do not draw that much power. These 4 batteries will most likely get you through the night. Don't quote me on that, but like I said, built this primarily because I already have these batteries laying around. If you have Ryobi batteries, build the Ryobi system. If you have a lot of Makita batteries, build it with that. Whatever you got. You could technically change this up to car batteries or whatever if you needed to. I wouldn't do that because it's just too heavy to lug around and stuff, but this helps. If I'm in a network rack situation where they don't have power out yet, I can easily run a bunch of network devices from here. So pretty walk in the park. Like I said, not everything 100% quote by the book, but we took relatively safe precautions. So hope this video has helped you guys out. I'll throw up the wiring diagram one more time, so if you want to freeze it, take a screenshot, whatever, you can do that. Like I said, I'm not telling you to do this, so do not hurt yourself. If you don't know what you're doing, don't do it. Be very careful when you're wiring any of this stuff so that you do not short it out, okay? The Milwaukee and Makita battery packs have the BMS systems that protect it from overcharging or pulling too much from it, or under voltage, meaning over depleting the battery packs built into the battery packs. The DeWalt ones, I don't think that they do. The last time I opened one of these up, it didn't seem like the BMS was on here. I could be wrong. They made an update since then, but last time I checked, they were not. So when it starts beeping due to low battery, you need to make sure you take care of the DeWalt battery packs, because you don't want to damage them. So I mean, the reason I went with the DeWalt ones because I have a lot of DeWalt ones, and these are pretty much 6 amp hours. I know they make 12 amp hours now, but you could go with the Makita ones too if you want. So just keep that in mind. Don't damage your batteries. And hope this video has helped you guys out. And if it's helped you guys out, then let me know. If it doesn't, then let me know why, and then we'll try to fix that for you sometime in the near future. So there it is. All you really got to do is put it in the box. I'm going to put it in the box and add another additional pigtail for more batteries into it. I'm not going to show you that this time, show you that in the previously. So here it is. Good luck, and we'll see you guys next time.